All right, good morning. Happy Friday, guys. How did the test go? Hello, anybody there?
Ms. Birch,
Yeah?
there was actually a difficulty on the computer and I couldn't take the test.
Okay, you have to talk to me later about it.
Okay.
Yeah. How did the test go? Everyone who took it?
Was good.
Was it pretty much what you expected?
Yeah, it was what I expected, to be honest.
Okay. Anyhow, I'm teaching a new lesson today. But I'm gonna talk a little bit about the final first. So this is finals week. It's coming up, not next week, but the week after. So I do want to talk about it. So on this Monday, we're following a Wednesday schedule. So instead of the following your class meetings for Monday, Tuesday, Thursday, Friday, you're going to follow the Wednesday schedule on this Monday. Okay, on Tuesday, our finals 1 and 4. On Wednesday, our finals 2 and 5. Thursday, our finals 3 and 6. And then on Friday is a teacher prep day, which you are not required to come to class. All right, so now these are 2-hour finals. So this first final starts at 9:25 to 11:25, and the second final each day starts at 12 and goes to 2 o'clock. Okay, so I did post today the final schedule. It is posted on the Colton High School webpage, so it's all over the place. So make sure you know. It's important because if you miss the final, you get a 0, and that's 20% of your grade. So there's no wiggle room here at all. It's a really scary time, for me, because it's like, if you miss the final, you wake up late, you can't take it. And that's why we've been practicing all year to make sure that you have Wi-Fi, that you have internet, that you have the Chromebook, because now things can't go wrong. You have to be able to take the final on the day it's given because there's no wiggle room in the schedule. With that being said, I want to talk about the benchmark that you took on Wednesday. Half of my students did not get the remind message that said, make sure you submit it on time. Because half of my students did not submit it on time, and guess what happened? It cut them off, it did not grade their test, and it did not record it, which means if that were the final, they would have got a 0. So I'm not messing around, guys. I'm being really serious about this. You have to pay attention to the time. So what I would do, I would set an alarm on your phone. I would set an alarm in your kitchen. I would have your mom come in and tell you. But I would say 5 minutes before the final's over, you have to submit it, because if you submit it late, you will get a 0. I hope I'm making myself clear. So anyhow, the benchmark was a practice. So it's going to count as an assignment, but it was a practice for the final. On the testing platform Illuminate, that's where the final is going to be given. Make sure that you turn in the final before the test shuts off. If the test shuts off, it will not record it. You will get a 0, and it is 20% of your grade. Now, I have not seen the final, but I'm willing to bet that you're going to see those problems that I gave you on the final. It was a district benchmark. This is a district final. And so these are the problems that they want you to know how to do. So between now and then, if you don't know how to do these problems, and by the way, all the distractors were mixed up. So every student had a different test. If you don't know how to do these problems, you need to contact me or we need to work them so that you know how to do them, because I'm willing to bet you're going to see these problems again. So you're going to see them again, okay? And if they're going to be on the final, I'm thinking. All right, so not very good practice run, but that's why I wanted to do it, because I wanted to make sure you understand, you know, that this final is a very serious thing and you can't mess it up. Okay, any questions about the final? All right, well, today I'm teaching a new lesson on 7-1, and I need you guys to just wake up for a little while to just make sure you take good notes, okay? Because I'm going to show some lengthy problems, and I may not be teaching like the book, so I'm going to give you some really organized notes. And basically what we're going to do today is we are going to solve higher degree polynomials, but this time they're not going to give you a root. They're not going to give you a factor. They just give you a polynomial and they say, find the zeros, find the roots. All right, so I want to show you how to do this. So this is a very important lesson. This is a lesson that it brings everything we've been doing together. So everything we've been doing is going to be in these problems. All right, guys. You guys okay? You out there? I don't see you, so.
Yeah.
Okay. All right, you guys. This is finding, well, it's finding rational solutions, but we're going to find them all. Now, when you see the word rational, it means anything that could be written as a fraction. But today we're going to find all the solutions. But just to let you know, rational rhymes with fractional. So 3 can be written as a fraction, so that's rational. 2/3 is rational. -7 can be written as -71, 7/1, that's rational. 9/10, anything that can be written as a fraction, fractional, rational. So what would not be rational? Something like square root of 2, that's not rational because that's a non-terminating repeating decimal. So anything like that, or any like kind of decimal that doesn't repeat a pattern, those are irrational. Rational, irrational. Now I realize that this says we're going to find the rational solutions only, but since 7-2 is going to have you find all the solutions, we're going to find all of the solutions. Polynomial equations. Hopefully I'm going to teach this really good today. Things are going to be clear, hopefully, from how I've trained you before this. So you'll be able to do this. It is a lot of work, so I'm just telling you, it's a lot. Okay, this is the California Common Core Standard. Okay, you ready? All right, here we go. So they're going to ask you to find the zeros. In other words, solve it. Find the answers, find the solutions. Okay, let me give you the problem and let's just get started. I think the less talking I do and the more I show you is going to be better anyway. Minus 19x minus 20. Now remember before, we could do grouping 2 by 2 and we could break the cubic down. Can't factor. Remember before when they gave you they gave you a factor or a root and you were able to do synthetic substitution. We don't have a factor or a root. We just have this polynomial. So it's like, what the heck do we do? Well, we're going to do something. We're going to use something called the Rational Zero Theorem, and we're going to make a P over Q list. So those are going to be the factors of P, and this is 1. These are going to be the factors of Q. Now, this is actually one of the easiest problems I'm going to work today because the leading coefficient is 1. So when the leading coefficient is 1, you don't have this in your book, but I know this. There's something called the Integral Zero Theorem that's going to make this problem easier. So we're going to write the factors of P. Now, P is always the constant. And you know what factors are, right? Numbers that multiply to give something. So plus or minus 1, plus or minus 20. So some combination of those, like a negative 1 times a negative, negative 1 times a positive 20 is negative 20. A positive 1 times a negative 20 is negative 20. So we always put plus or minus in these lists. So plus or minus 2, plus or minus 10, plus or minus 4, plus or minus 5. So those are the possible rational numbers that multiply to give negative 20. So guess what you're going to have to do? We don't have to do a Q list. So if you're wondering, why isn't she doing a Q list? Because when this number is some number other than 1, we have to do a Q list, and then our possible rational zeros are a P over Q list. But we don't have to do that because the leading coefficient is 1. It's a special case. So watch what you have to do. Now, we're going to do this off to the side of the paper. So we're going to put in 1 and do synthetic substitution. So 1, 2, negative 19, negative 20. And what we're looking for is a remainder of 0. Because if we find a remainder of 0, we found a solution, right? We found a 0, we found a root. Okay, here we go. Bring down the 1, multiply, add. Multiply 3 is negative, what is that, 16? Multiply negative 16. No, that didn't work. So now we have to try negative 1. If that doesn't work, we try 2, negative 2, 4, negative 4, 5, negative 5. So you might have to do synthetic substitution 2, 4, 6, 8, 10, 12 times. Now we might get lucky with this. So let's see what happens here. So I'm putting negative 1 in the box now. So bring down the 1. That would be negative 1, 1, multiply. That would be a negative 20, positive 20. We found a root. Now, like I said, I don't want to see this garbage. So I don't want to see you doing this 50 million times. I want to see the one that works. So over here, you're going to put the one that works. This is negative 1, and it's going to be 1, 2, negative 19, and negative 20. Bring down the 1, negative 1, 1, negative 1, negative 20, positive 20, 0. Okay. So we found a root. Or a solution. So now you're going to write a product of factors, and you're going to set it equal to 0 this time because we're going to solve it. So if this is a root, a factor would be x plus 1, correct? And this would be the other factor, which is a quadratic, because we have to drop it down a level. So this would be 1x squared plus 1x minus 20, right? And these are the factors that multiply to give the polynomial. And now we pray that we can factor this. If you cannot factor that, which you're going to have problems that can't be factored, you're going to have to use the quadratic formula. But that might factor. And I think it does because I started these problems out easy. Okay, so what we have here, we're going to try to factor 0 is equal to x plus 1. And this looks like factoring method 5. What multiplies to give a negative 20 and adds to give 1 would be a positive 5 and a negative 4. And yes, thank goodness, it did factor So what are our solutions? Go ahead, I'm listening. What are our solutions?
-1, -5, and 4.
And how many solutions were we expecting? Go ahead, I'm listening. How many solutions were we expecting?
3.
3, because of the degree. So this problem wasn't so bad. We were able to find a root right away. We didn't have to go do a bunch of synthetic division and try 20 and it, you know. We were able to factor here, right here, which is not always going to be the case. Sometimes you have to use the quadratic formula. But anybody want to ask me any questions right now? So let's go on to another problem. Same thing. This is all we're doing today are these types of problems. You want to keep your work really organized. You'll get lost in it. Wow, that red. Thanks. Okay, let's do another one. This is a quartic. I'm gonna start all the way up here. You guys see this? So this one, it's f of x is equal to x to the 4th minus 4x cubed minus 7x squared plus 22x plus 24. Now listen, you guys, you want to factor wherever possible. So make a note here, factor wherever possible. And what do I mean by that? Well, if you could do grouping here, which you can't, there's 5 terms. If you could do a GCF, if you could do any type of factoring, do it. Can't. So luckily, this is an easy problem because we can use the integral zero theorem. So we don't have to do a P over, this is the P list. Normally, if that number's different, which you'll see in a minute, we have to do a P over Q list, but now we're just doing a P list. So the possible rational zeros would be plus or minus 1, plus or minus 24, plus or minus 2, plus or minus 12, multiply to get 24, plus or minus 3, there's a lot of them, plus or minus 8, plus or minus 4, plus or minus 6. Now, guess what? When you try a 1, for synthetic, it's not going to work. When you try -1, it's not going to work. When you try +2, it's not going to work. When you try -2, it's not going to work. So finally, when you get to a +3, it's going to work. Now, how do I know that? I'm cheating. I'm looking at the answers. Remember, I have the key. You don't know that. So unfortunately, you have to go through all this work. And that's why you're doing it on scratch paper somewhere else. I don't want to see that garbage. So do it on scratch paper. I only want to see the one that works or the ones that work. Okay, so back over here. So this would be a 1, a -4. Make sure these are all shown too, because remember, you need a placeholder if one's missing. And if you forget the placeholder, you're going to be looking for these rational zeros and you're not going to find any because like nothing's going to work. Okay, bring down the 1, multiply, -1, -3, -10, -30, -8, -24. Look at, see, I found a 0. That means I found a root or a solution or an answer or a 0. So now we're going to set this equal to 0 because we're solving it. Normally, And on that past test you took, you wrote f of x, right? You wrote a product of factors that represented the polynomial. Now we're setting it equal to 0. Okay, here we go. So if 3 is the root, x minus 3 is a factor, and this is also a factor. It's the depressed polynomial, which is down 1 degree. So this would be 1x cubed minus 1x squared minus 10x minus 8. And it's like, try to group. Looks like grouping, group. Can't. You can group, but you can't get the cakes to be the same. So it's like, oh, great. Well, how do we break down a cubic? Can't use the quadratic formula. We have to do another P over Q list. But we only need the P list because this is a 1. So we're going to do a P list on -8. So you do plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Those are the factors that multiply to give it -8. And now we go through the same thing again. So we try 1, it's not going to work. We're going to try -1, 2, -2, 4, and 4 is actually going to work. And the only reason I know that is because I'm cheating and looking at the paper. Now, let me ask you a question. If 3 was in this list again, which it could have been, could 3 work again? So 3 worked once. Could it work again?
Yes.
Yes.
Oh, yes.
Because of multiplicity. Because of remember, we could have x minus 3 times x minus 3, right? So just because it works once, don't think, oh, it can't work again. It can work again, but there's no 3 on our list. So we don't need to worry about it. Okay, so now what we're going to do is we're going to write these coefficients. 1, -1, -10, -8. Bring down the 1, multiply, add 12, add 8. Look at, I found another root. So we're slowly but surely breaking down the quartic. Now, you want to make sure you write your product of factors. So this is going to be 0 is equal to, the first one was x minus 3, so don't forget him. The second one's going to be x minus 4. And now we went from a quartic to a cubic. Now we're going from a cubic to a quadratic. 1x squared plus 3x plus 2. And it's like, oh, great, let's factor. It can't. So you want to try to factor the quadratic, but it doesn't work. So guess what? Have to use the quadratic formula. I know, horrible, right? So don't do this in line with, I don't have enough boards, so I'm just going to do this right here, but don't do it in line with your work. Okay, so here's the quadratic formula. And we're doing x squared plus 3x. So A is going to be 1, B is going to be 3, C is going to be 2. And I'm going to do this real quick. So x is equal to -b plus or minus square root b squared minus 4ac all over 2a. So this is -3 plus or minus the square root of 9 minus 8. I don't know, there's a problem. That isn't working out right. Or did it factor? Oh my gosh, you guys, look at it, did factor. We got lucky. We don't need to do this. It did factor. Factoring method 5. Oh, good. How does that factor, guys? What multiplies to give 2 and adds to give 3?
2 and 1.
Yes.
Yeah. Yay! We don't have to use the quadratic formula. What makes that 0, 3? What makes that 0, 4? What makes that 0, -1? What makes that 0, -2? And how many solutions were we looking for?
4.
4, right? So that problem wasn't so bad either. It was bad here because we had to do another p-list. Yeah, because we couldn't factor, we couldn't do grouping. So whenever you're just completely stuck, you have to do a p over q list. Right now, our coefficients are 1, so I haven't talked about q yet. I'm going to talk about q right now, though. Do you want to ask me any questions about anything so far? So it's not that
Miss
it's
Bird,
hard.
where
What's
did you
that?
get the 13 from? In the right there on the second board, the first equation. I don't know where you got that 13 from.
That's not a 13. That's actually a plus.
Oh, okay, thank you. Sorry, I just seen it wrong.
That's okay, babe. Right here, look at x squared plus 3x plus 2. I know, when I looked at it a second time, it looked like a 13 too, and I took a double take too. Sorry about that. Okay, let's do one now where we have to do a p over q list, where the leading coefficient is not 1. So this could be a real mess. So remember, we're trying to find the possible rational zeros. So this method that I'm teaching right now, we can't find irrational zeros. We're finding the possible rational ones. But I'm asking you to find all the solutions. So take a look at this one. I'm going to write a little bit smaller because I have a lot of work to do on this. So look at this is the quartic again. 4x to the 4th minus 21x cubed plus 18x squared plus 19x minus 6. Oh, brother. Well, can we do a GCF? No, it doesn't work. Can we do grouping? No, we have 5 terms. We're just stuck. So when you're just stuck, you got to do, now look at this. This is going to be a P list, and this is going to be a Q list because we can't use the integral zero theorem. So the P list, you guys got to mute yourself. The P list is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And now the Q list is always the leading coefficient. So the P list is the factors of the constant. The Q list are the factors of the leading coefficient, which would be plus or minus 1, plus or minus 2, plus or minus 4. Now, you're not going to believe this, but what we have to do to find our possible rational zeros, we have to put all those guys over 1, all those guys over 2, and all those guys over 4. So we're going to create a big old long list of possible rational zeros. So here we go. So all those guys over 1 are just themselves. All those guys over 2 would be plus or minus 1/2, plus or minus 2/2, plus or minus 3/2, plus or minus 6/2, and I'll get rid of the duplicates in a minute. All those guys over 4 would be plus or minus 1/4, plus or minus 2/4, plus or minus 3/4, plus or minus 6/4. So 2 over 2 is the same as plus or minus 1. 6 over 2 is the same as 3. 2/4 is the same as 1/2, and 6/4 is the same as 3/2. So we got rid of a few of them. And of course, I'm going to try 1. It's not going to work. I'm going to try -1. It's not going to work. I'm going to try 2. And I think it's going to work. So let's see. So like I said, in line with your work, only give me the one that works. So the coefficients for synthetic substitution would be 4, -21, 18, 19, and -6. And I'm not missing any powers, so I'm good. So bring down the 4, get an 8. This would be what? Negative 13, negative 26, negative 8. Negative 16 is a positive 3 and a positive 6. Yes, I found a solution. So we're going to write the product of factors. And I'm setting it equal to 0 because we're solving it. So this would be x minus 2. And your depressed polynomial, we started with the quartic. And now we're writing a cubic. The cubic would be 4x cubed minus 13x squared minus 8x plus 3. Okay, I'm going to try to factor by grouping. Yes, I can do grouping, but it doesn't work because things don't match up. And so, shoot, we have to do another P over Q list. So here we go. So the P list now is plus or minus 1, plus or minus 3. So at least we cut the list down. And then the Q list would be plus or minus 1, plus or minus 2, plus or minus 4. So I'm going to try to write down here, running out of board space. So put all those guys over 1 would be just themselves. Put all those guys over 2 would be plus or minus 1/2, plus or minus 3/2. And then finally, plus or minus, hold on, I got confused. Those guys over 1, those guys over 2, those guys would be plus or minus 1/4, plus or minus 3/4. So here's what really stinks. You're going to try 1, negative 1. You're going to try all these, but guess what works? Negative 3/4. How do I know that? Because I'm cheating and looking at my paper. So you're going to bring your 4, negative 13, negative 8 and 3. And you're going to take negative, off to the side of the paper, negative 3/4 times, or I'm sorry, 4 would be negative 3, add negative 3/4 times negative 16 is negative 4, which is a positive 12, add. Negative 3/4 of 4 again is negative 3, and that's how we find the 0. Now, I'm going to add something else here. This factor, remember I told you that you couldn't have factors like this? But if you write it like this, you can. And I didn't want to tell you that earlier, but these are the same, right? So when I write my product of factors, I'm going to write it like this, but these are the same, because what makes this 0? Negative 3/4. What makes this 0? Negative 3/4. And we just looked at that on the benchmark. But anyhow, we'll get back to that. All right, so anyhow, we're going to write our product of factors. We found another root. So what's the product of factors? Well, don't forget about this guy. X minus 2 is a root. Now we have, what did I say it was? How did I say to write it? 3x plus 4. No. 4x plus 3. Yes? That work? -3/4? And then now the depressed polynomial, we went from a quartic to a cubic, and now we're going from a cubic to a quadratic, 4x squared minus 16x plus 4. Now look what I'm going to do right away. What I'm going to do right away is I'm going to take out a 4 out of there and put it in front. So when I take out a 4 there, you're not taking a 4 out of everything, just there. This would be x squared minus 4x plus 1. And guess what? That doesn't factor. So we have to use the quadratic formula. So let me do this real quick. You're not going to do it in line with your work. It's x is equal to negative of a -4 plus or minus the square root of b squared would be 16 minus 4 times 1 times c, all divided by 2 times 1. X is equal to a +4 plus or minus the square. That's 16 minus 4 is 12. You have to simplify the radical. So it's 2 times 2 times 3. So that's 2 radical 3. And now you have to simplify all 3 terms, which would be 2 plus or minus radical 3. Okay, write this down because I have to erase it. I don't have any boards. So this is 2 plus or minus radical 3. We have to write a product of factors. Can I erase this? Right here? Yeah.
Ms. Birch.
You guys, can I erase this right here?
I finished.
Okay, can you guys please take a picture of this and then, because I got to erase it. I got to get going here. So can I erase this, please?
Yeah.
Yeah. Ms. Birch.
Yeah.
How you took out a 4, wouldn't the second binomial 4x plus 3 change to just x plus 3?
No, hun. I know. I always wondered about this too, but think about it. If I take a 4 out of there, when I multiply this out, you don't distribute a 4. There's no pluses in between there. This is a product. So I could put the 4 with these 2 guys, or I could put the 4 with those 2 guys, or I could put the 4 with those 2 guys. So you're not distributing. Remember distributing? You distribute when you have pluses or minuses in the middle. There's no pluses or minuses, so you're not distributing. But that question, that is a very, very good question. Because that, when I was in school, and actually when I was teaching initially, that confused me. Like, can I do that? I mean, can I do that? But do you see how you're not distributing a 4? You could put the 4 with either one of these 3. And so see how you would get, you didn't change the problem at all.
Yeah, okay.
Are you convinced, or I'm going to still
Yeah.
talk? Okay. Okay. You're welcome. All right, so watch this. So now the other 2 factors that we found had a radical. That means they're irrational. So watch how you're going to write it. You always write it like this. So listen carefully. If you get 2 imaginaries or 2 radicals, you always, that's a strong statement, you always write them like this. Okay, what was the answers I got? I can't remember, I erased it. What was one of the answers? Was it 2 plus something?
2 plus radical 3.
And the other one was, thank you, 2 minus radical 3. So watch, the way I'm teaching you this is really easy. Watch. What makes this 0? Itself. What makes this 0? Itself. So what are your solutions? 2, -4/3, 2 plus radical 3, because what makes that 0 itself? And the other one is 2 minus radical 3. And so like I said, in this lesson, they only wanted you to find the rational roots, but we're finding all of them because you're going to have to do that in 7 too. So I'm just giving you practice in both. So we found, not only did we find the rational ones, there's 2 rational ones and 2 irrational ones. Those are your 4 roots.
Instead of -4/3, wouldn't it be -3/4?
I don't know. Let's see. 4 times, it is -3/4. -3/4 plus 3 would be the 0, right? Yeah. So is it right now?
Yeah.
Okay. Thank you. Thanks for seeing that. So these right here are irrational. So basically, I mean, this isn't hard. It's just a pain because it's just so much work. But what we did, to make a long story short, we broke down the quartic. We broke down the quartic to a product of factors that we could solve the polynomial. And this is the process we go about to do it. And now we know that with a factor like this, we can actually put a fraction in here and get a 0. We just have to be careful how we write things, but it's nicer to write it this way than to write it as x plus 3/4. Okay, now I'm going to work a couple of word problems, but do you guys want to ask me anything about the process? Okay, do you understand how I told you how to write the roots for the irrational or imaginary solutions? You always write x minus, always. It's always x minus, and you put the irrational number in there or the imaginary, works the same way. Do you guys want to ask any questions? So for you, it's even going to be more work than this because I cheated. Remember, to get the rational zeros, I was looking at my notes. You're not going to have any notes to look at. So you might have to do synthetic substitution, a few times. Searching, you're trying to search for, see, if you're working in teams, if you're truly working in teams, somebody could check 1, somebody else could check -1. And if you're working together, if you're collaborating, that would help. If there's 4 people, you could get everybody a number and let everybody find a root. Now, let me tell you something. One team might find 4 to be a root, and another team might find 3 to be a root. It doesn't matter which root you find. The work's going to all look different, but you're going to come up with the same answer. So it doesn't matter if somebody finds one root and you find another one, a different one. The work's going to look different, but you're going to come up with the same answer. Okay, now I want to make a couple notes here. Just write this down. Finding zeros, you heard me talking, is the same as finding solutions or roots. So these words are all the same. Finding zeros is the same as finding solutions or roots. And then just write down that rational means fractional. Okay, now the word problems are not bad. So look on page 345. It's the engineering problem on page 345. Hey, by the way, did you guys get my message about going to school and getting the volume 2 of your book? So your book is not the whole book. Your book, if you look on the front, is only volume 1. You need volume 2. So next week, go and pick it up. Okay? And do it right away, because I don't know how many they ordered. And I told them, are my students are there going to be enough books? So you just want to make sure that you get a book, okay? They supposedly have enough, but you know how that goes, you know? So make sure you go next week. I think that the school's open, Monday, Wednesdays, and Fridays from 8 to 11, and make sure you get your volume 2 book. All right, you guys, thanks for hanging there with me. This is on page 345. It's the engineering problem. All right, so check this out. It says a pen company is designing a gift container for their new premium pen, and the marketing department has designed a pyramidal box. Now, we don't have very many square-based pyramids, but there are 2 near us. In Las Vegas, there's the Luxor, which is a square-based pyramid. And in Long Beach, the Long Beach State men's basketball team, they play in the place called The Pyramid. They play basketball in there. So it is a pyramid. If you've ever been down to Long Beach, you can see it from the freeway. So it is a pyramid. Now it says the base, they start giving the dimensions. The base width is 1 inch shorter than the base length, and the height, this is the confusing part, and the la. So let's break it down here. Everything is based on the length. So let's let the length equal x. So here we go. It says the base width is 1 inch shorter than the length. That was easy. And the height is 3 inches taller than 3 times the length. So 3 inches taller than 3 times the length. 3 inches taller than 3 times the length. So the volume of a rectangular box is length times width times height. This isn't rectangular. This is pyramidal. So you would have to look up I looked it up for you. It's 1/3 times the length times the width times the height for the volume. So just put it in. So the volume in terms of x is 1/3 times x times the width times the height. Now, Guadalupe, watch this. Watch this. I'm going to take out a 3 here. GCF. When I take out a 3, look what happens. That's all the product, isn't it? And if that's all the product, can I cancel the 3s? So now I have this. Watch this. Isn't this the difference of squares? Isn't that x squared minus 1? Isn't that the difference of squares? And so we get x cubed minus x. So it's like, oh, great. We have a cubic. Well, the volume, they told us that the volume is 6. Let me read it again. It says the volume is 6 cubic inches. So look at this. I can put 6 in here. And now I'm going to set it equal to 0 and get x cubed minus x, subtract 6 from both sides. And now I have a cubic and I can solve for x. It's not nice because I'm going to have to do a p-list. So they're not giving me any hints here. So this is a 1 though, so I can use the integral zero theorem. So the p-list is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So this is the p-list. Q is 1, so we're good. And it's like, okay, we got to do all this testing. So you try 1, it doesn't work. So try 2. So this would be, now look at this, look at this. There's a square missing. There's a square missing, so don't forget a 0 there. -1 and -6. If you forget the 0, you're going to be doing a lot of testing and not finding anything. So bringing down the 1, multiply, add, multiply, 3. Yes, I found a 0. So what's your product of factors? Now we're trying to solve this. So this would be x minus 2. And this depressed polynomial from a cubic would be x squared plus 2x plus 3. And that's not going to factor. Now listen to this one. This is a real life problem, right? If this is a real life problem, we can't have imaginaries. So I'm going to cheat. And I'm going to use the discriminant and see if I have it off to the side of the paper. I'm going to use the discriminant and just see if those are imaginaries, because I'm not looking for a bunch of different lengths. I'm looking for one length for x, right? I mean, it only makes sense to me. It's gonna be one length. So watch this. This would be 2 squared minus 4 times 1 times 3, which is 4 minus 12, which is -8. Guess what? These are complex. And that means they're imaginary. And it means that since my discriminant's negative, I'm not even going to mess with that anymore. I know my only answer is 2. So now I'm going to find the length. So the length is x, which would be 2 inches. The width is x minus 1, which is 2 minus 1, or 1 inch. And the height is 3x plus 3, or 3 times 2 plus 3 is 9 inches. And that is the problem. So if it's a real life problem like this, in real life, unless we're dealing with electric circuits, we're not dealing with imaginaries. They wouldn't make sense as far as length goes. So I kind of cheated and said, I'm just going to do the discriminant really quick. And if I get a negative discriminant, that means I'm not finding the solutions. I know the nature of the roots are imaginary, so I can just throw it out. Okay, I'm going to do one more of these, and then I can take questions. Are you guys okay?
I'm good.
This is like everything we've ever done, right? And the district said, don't teach this. And I'm like, I'm teaching this. This is why we did everything that we did. And to not teach this would not show you why we did everything that we did. So what we're doing now, we're solving think about it, we're solving a higher degree polynomial with no hints. So we're using everything we've learned to solve the polynomial, to find out where it's crossing the x-axis. In this case, we're finding this information for this pyramid. Okay, you guys, I'm almost done. Hang in there. You're doing a good job hanging in there. I'm going to do one more problem, and it's another box problem. It's on page 346. Okay, so it's on page 3. It's another engineering problem. Let me read it to you. A box company is designing a new rectangular. Okay, so now this is going to be easier. So they're designing a rectangular gift container. The marketing department has designed a box with the width, it's 2 inches shorter than the length, and the height is 3 inches taller than the length, the length. So we're going to make the length x. And we're going to need the width and the height. So let's go back and read it. It says that a width 2 inches shorter than the length. 2 inches shorter than the length. And a height 3 inches taller than the length. 3 inches taller than the length. So now we have our regular volume of a rectangular box. And so in terms of x, we have x times x minus 2 times x plus 3. Easier than the previous problem. So we're going to multiply this out. So first, outer inner would be 3x minus 2x is x minus 6. So this would be x cubed plus x squared minus 6x. And I think that they say that the volume is 56, is it cubic inches? So we could put 56 in here, and we could set it equal to 0. So subtract 56 would be over there. And it's like, okay, well, I'm going to try to factor by grouping. So I take out an x, it's not going to work. So luckily, this is a 1. So we don't have to do a P over Q list. We can just do a P list. Plus or minus 1, plus or minus 56, plus or minus 2, plus or minus, what is that, 28? Yeah. Plus or minus 4, plus or minus 14, plus or minus 7, plus or minus 8. There's a whole bunch of them. And it's like, okay, 1's not going to work, -1's not going to work, 2's not going to work, negative. You guys want to try 4? Remember, I'm cheating. I'm looking at the paper. So let's put this down. 1. I think all the powers are shown -6, -56. So bring down the 1, multiply and add. multiply would be 20. That would be a positive, what, 14? And that's a positive 56. And I found a root. All right, now remember we're trying to solve this. So set it equal to 0. What do you get? You get x minus 4, and this depressed polynomial from the cubic is x squared plus 5x plus 14. And it's like, please let it factor, but it doesn't factor. Oh, brother. Well, it's a real life problem, so let's just look at the discriminant. So if you look at the discriminant, that would be 5 squared minus 4 times 1 times 14, which is 25 minus 56, which is a negative, what is that? 23? No. What is that, a 1? 3? Is that right? Negative 31? So what does that tell you? That tells you that these are imaginary. And so we have one solution for them. So we didn't have to go and use the quadratic formula. This is a real life problem. So I use the discriminant to tell me the nature of the roots. And now we can find the information. So the length is x, which is 4 inches. The width is x minus 2, which is 4 minus 2, which is 2 inches. And the height is x plus 3, which is 4 plus 3, or 7. Okay, so a couple reminders. Okay, first of all, you normally have to do a P over Q list. But when the leading coefficient is 1 or negative 1, you can use the integral. Integral means 1. So the integral zero theorem only allows you only have to do the P list. When this is some other number like 2, 3, 4, 5, you have to do a P over Q list. Remember that when you do the synthetic substitution over and over again, if you get a 0 as the remainder, you found a solution. Make sure that you write a product of factors. And in a word problem like this, when you have a quadratic that you can't factor, you can use the discriminant to tell you the nature of the root, and if it's complex or imaginary, then
Wait.
it's let out.
But how do we know if the number is complex or imaginary?
Okay, well, this is a real life problem. Oh, you mean how do I know from this?
Yeah.
Well, remember the discriminant. If the discriminant's negative, it means you have 2 imaginaries. If the discriminant is 0, it means you have 1 real root. And if the discriminant is positive, it means you have 2 real roots.
Okay.
So if it's negative, 2 imaginaries. If it's 0, 1 real root. And if it's positive, you have 2 real roots.
Okay, thank you.
So you might be wondering, well, how did I know to use the discriminant there? Because think about it. There's probably, x is probably only 1 number, right? This is a real problem. So I'm not thinking x is 3 different numbers. So if x is 1 number, it means that I was looking for 1 answer. Now, if this had been a math problem, I would have been looking for 3 answers. But this is a real life problem. So even though I had a cubic, I figured that 2 were going to be imaginary because I was looking for 1 solution to fit in here.
So what would happen if we had two real solutions with discriminant? Would we have to solve with the quadratic formula, and would it mess with our answer?
Yeah, you would have to use the quadratic formula and find the two solutions. Yeah. Yeah. So see why you want to know how to factor now? Because you don't want to do all this work and have to do the quadratic formula. So like if this would have factored, we could just do it in one step. You know, so we don't want to use the quadratic formula now. It's too much work because we have a lot of other work we're doing. So now the synthetic substitution is busy work, and the quadratic formula is busy work, and the factoring is busy work. So that stuff is just the tools that we're using to get what we want, but that's not the main show now. We're using those tools to do other things. So yeah. Okay, listen, since you took that exam this morning, I'm going to let you guys go. It's a little bit early. If you want to hang out with me and ask me questions, that's fine. But I hope you guys have a fabulous weekend. Okay. And yeah, have a good weekend. Okay. And make sure that you know how to do those problems on the benchmark. All right. Okay. Have a good weekend. If you want to hang out with me, you can.
Bye,
Bye,
Miss
guys. Have a good
Bird.
weekend.
Have a good
Bye,
weekend.
Ms. Birch.
Thank you.
Bye.
Thank you guys. It's good to hear
Have a
you.
great weekend.
Bye,
Ms. Bird.
guys. Bye, guys. Have a good weekend.